Today we're going to take a look at creating equations of lines given different information. So we'll be given slope-intercept form, where we're just given slope and the y-intercept, and then we could graph from there. Might have to use point slope, where we're just given slope and some random point on the line, or maybe just given 2 points. So we're looking at a lot of different scenarios here in this video. So slope-intercept form is the form of y equals mx plus b, where m is the slope and b is the y-intercept. So when we go to graph, the y-intercept being the b value, where that's going to be our starting point, and then our slope indicates our movement from there. So the slope is the up and down movement over your right to left movement, your rise over run, change in vertical distance over the change in horizontal distance. So there's a lot of different ways that we can identify slope and understand slope. So let's just jump into some examples. So the first one, use the slope-intercept form to graph the equation y equals 2/3 x minus 1. So this is already in slope-intercept form, y equals mx plus b, where m is the slope. So in this case, y equals 2/3 x minus 1. 2/3 is the slope. So the slope is 2/3, and then the y-intercept is that -1. So let's just plot the point of -1 on the y-axis. That's our y-intercept, so I'm going to put a point at -1. And then my slope is 2/3. So how do we translate that slope of 2/3 into the actual graph? Well, 2/3 means the top number is positive, so that means I'm going to go up 2. Bottom number is positive, so that means I'm going to go right 3. So from that y-intercept of -1, I'm going to go up 2 to the right 3, up 2 to the right 3, and so on. So up 2, 1, 2 to the right 3, put us right here. Up 2, 1, 2 to the right 3, 1, 2, 3. I'm a little close to my camera here. So again, what I did is I started the y-intercept of -1. Whoops. Started the y-intercept of -1, went up 2, 1, 2, and then I went over 3, 1, 2, 3. Up 2, 1, 2, 1, 2, 3. And you could do quite a few points. I would get in the habit of trying to do up and to the right, and then doing the opposite, so down and to the left. So then you can go down 2, 1, 2, to the left 3. So that gives you just a little bit more of a general idea of what this graph is going to end up looking like. So then here is my line of that. Number 2, graphing this equation, -3x minus y equals 3. So here, we don't have it in slope-intercept form. We don't have it in the form of y equals mx plus b. So we have to do some work. I have to add 3x to both sides. I get -y equals 3x plus 3, because I just added 3x over. Now I have to get y by itself by dividing by -1. Get y equals -3x. 3 divided by -1 is -3. 3 divided by -1 is -3 again. Let's identify the key components here. So the slope is -3 over 1, and the y-intercept is also -3. I'm going to use the same graph here. So we have a negative slope, which is going to change the look to this graph. Negative slope is going to be down and to the right. So y-intercept is -3. Put a point at -3. My slope is -3 over 1. So now since the negative is on the top, we want to go down 3, and we want to go right 1. Down 3 and to the right 1. Down 3 and to the right 1. So from my y-intercept of -3, I'm going to go down 3, 1, 2, 3, to the right 1. If I keep going, I'll run off the graph, so let's just get in the habit of doing the opposite. So if I went down to the right, I could also go up and to the left. So I'm going to go up 3, 1, 2, 3, to the left 1. 1, 2, 3, left 1. And then that would give us a good idea of what this line looks like. I'm like way off. Let me redo that. So there it is. Not the best line, but you get the idea. Number 3, find the equation of the line with the y-intercept 0, -2, and the slope of 1/2. So we want to get the equation, we want to gather the information, we want to gather the slope, the y-intercept, all that information. So we want it in the form of y equals mx plus b, and we have the y-intercept because they're giving us the y-intercept of 0, -2. Remember, with y-intercepts, that's when the x value is 0, where the slope is 1/2. So that's going to be y equals 1/2 x minus 2, the y-intercept being -2, 0, -2, slope of 1/2, so I could just directly relay that into the equation. y equals 1/2 x minus 2. And if we were to graph that, then you just put a point at -2, up 1 to the right 2, up 1 to the right 2, but not asking for a graph, so we'll just leave it like that. Go to my next page here. Point slope. So we're going to use point slope when we are given information that isn't the y-intercept, or we're given slope in some form, but mainly we don't have the y-intercept, so we have to use point slope. And now there are other ways to do this when you're just given information regarding the line. There's a lot of different methods, but I like to stick with point slope. So point slope is y minus y1 equals your slope times x minus your x1. So y minus y1 equals your slope times x minus x1. What are these y's and y1s and everything? So let's just say we have an ordered pair, x1, y1. And we have slope. Slope is whatever you want it to be. I'm just going to leave it as slope. This x1 and this y1 is this ordered pair. That's what that is. This y and x here, that's just the value of y and the value of x as it relates to slope-intercept form. Because what we want in the end is we want this equation. We want to go from point slope to slope-intercept, and then we generate a graph from there. So we go from point slope to slope-intercept, generate a graph. That's what this information is telling us. This is the ordered pair, the x1 and the y1, and then that y and x is just part of that slope-intercept equation, where we would end up, and then we'd be able to graph it from there. So on number 4, it says find the equation of the line with the slope -3/4 and passes through the point -8,3. So our point slope is y minus y1 equals m times x minus x1. This is the ordered pair x1, y1. This is the slope that they provided. So I'm just going to now plug this into point slope, and then we would solve and get it into slope-intercept. So y minus the y1 of 3 equals the slope of -3/4 times x minus the x1 of -8. Now we do have to clean this up a little bit. So right here, let me just go over this one more time. X minus a -8, it's because it's x minus x1. So x minus x1, that's going to be x minus whatever your x1 is. x1 in this case is -8, so we have to have minus a -8. I'm going to rewrite that. I'm going to go over here. Y minus 3 equals the slope of -3/4 times x. X minus a -8 is going to become x plus 8. And then we would distribute the -3/4. So y minus 3 equals -3/4 times x is -3/4 x. And then we have -3/4 times 8. -3/4 times 8. Be careful here. 4 goes into 4 once. 4 goes into 8 twice. -3 times 2 is -6. Solve for y. I'm going to add 3 to both sides. And that's going to give me y equals -3/4 x. -6 plus 3 is -3. So here is my slope-intercept equation. So after all that work, from here to here to here, after all that work, from this original point slope form, I'm able to now generate the slope-intercept form. And if they asked us to graph, we would just graph that, y-intercept being -3, slope being -3/4. So then we generate this graph, no problem. Now in the next one, I want to find the equation of this line through these 2 points. I'm not given slope, and I'm not given the y-intercept. I'm just given 2 points. So since we have 2 points, we have to calculate slope, and then we have to take that slope and take a point and plug it into point slope. So we have quite a bit of work ahead of us. So x1, y1, x2, y2, and the slope formula is y2 minus y1 over x2 minus x1. I'm taking these points, plugging into slope, getting the slope, and then I would go to point slope, because then we'd have the slope. And in point slope, we need the slope in order to solve for slope-intercept. So here we go. y2 minus y1 is 8 minus 2 over x2 minus x1, 4 minus 2. 8 minus 2 is 6. 4 minus 2 is 2. 6 divided by 2 is 3. So the slope here is 3. Now I have slope, so we could go to point slope now. So let's go ahead and plug this into point slope. So point slope is y minus y1 equals the slope times x minus the x1. Now we have point slope, much more manageable than the last one, because the last one we had a fraction, but it wasn't super difficult or anything, but a little bit more manageable. So 3 times x is 3x, 3 times negative 2 is negative 6. Add over that 2, y equals 3x, negative 6 plus 2 is negative 4. So here would be our slope-intercept form of the equation. Good problem there. We got to get slope, get point slope, and then solve it for slope-intercept. Number 6, find an equation of the line through this point. So we have another same type of exercise where we're just given ordered pairs, but there's a little bit of an extra challenge to this one that I created here. So let's go ahead and go through this. So this is our x1, y1. You don't have to label the points, but just getting in that, just making sure we understand where each number is coming from. Calculate slope. So the slope is y2 minus y1 over x2 minus x1. So the top, negative 1 minus 5 is negative 6. Negative 1 minus 3 is negative 4. So two things happen here. Negative over negative becomes a positive. 6 over 4 simplifies down to 3 halves. 2 goes into 6 3 times. 2 goes into 4 2 times. So our slope here is 3 halves. We have to take that slope, we have to plug it into point slope now. So y minus y1 equals the slope of 3 halves times x minus the x1. One side note I do want to make that I didn't make on this last problem. When we're using point slope here, when I plugged in point slope, you don't have to use the x1, y1. You could also use the x2, y2 if you wanted to. It doesn't matter. You'll still get the exact same, because this is just an equation. You'll get the same thing. So it's going to come out to be the same. So you don't have to use the technical ones. You could use the 2's also. All right, so let's distribute the 3 halves. So we get y minus 5 equals 3 halves times x is 3x over 2, or 3 halves x. 3 halves times negative 3 is negative 9 over 2. What's difficult about this problem is that fraction. Now we have this fraction of negative 9 over 2, because 3 times 3 was 9. It doesn't simplify with 2. So I have to add over this 5. So I get, let's actually go over here. So I have to do negative 9 over 2 plus 5. So you could use your calculator or just make this over 1, which if it's over 1, if you think back to adding fractions, this just becomes 2. This becomes 10 because the least common denominator would be 2. So 1 times 2 is 2, 5 times 2 is 10. And then negative 9 plus 10 is positive 1 over 2. Negative 9 plus 10 is positive 1. So we'd have y equals 3x over 2 plus a half. Plus a half there. So just be careful with those fractions. Number 7, find the equation of the vertical line through the point 2, negative 3. So remember we talked about with vertical lines and horizontal lines. Vertical lines look like this. So vertical is a vertical line. So it looks something like this. Now how do we create an equation just from the ordered pair? Well, if we know it crosses through the point 2, negative 3. So I'm just going to use this line that I just created. 2, negative 3. If I know this vertical line crosses through the point 2, negative 3, to create the equation, I just need to know what the x value is. So a vertical line is going to be x equal to 2, because it's just a vertical line. I'm going to use this same scenario, and let's just say it's asking for a horizontal line. Horizontal line this time. So if I want a horizontal line through the point 2, negative 3, so 2, negative 3 would be right here. If I want a horizontal line, that would look like this. So what would that equation be? Well, that would cross through the y-axis at negative 3, so then that would be y is equal to negative 3. So just understand the difference between vertical and horizontal. There's a couple problems left. Find the equation of the line parallel to the line y equals 2 and passing through negative 2, negative 5. So find the equation of the line parallel to this equation. What did we just talk about a second ago? Y is equal to 2 is a horizontal line at the y value of 2 and we want it to pass through the point -2, -5. I'm sorry. We want this line to be parallel to this line, but it passed through the point -2, -5. So that'd be somewhere down here. A couple different ways to do this. You can use point slope if you wanted to, but we understand that parallel means the slopes are the same, so the slope would be 0. So if I'm just like someone who's like, you know what, I like a formulaic method. I like just here's a system that I set up. Like here's how I just approach this every single time. If you're somebody like that, here's how we would do this. You would say y minus y1 equals the slope of 0, because it's parallel to a horizontal line, so it's the same slope, times x minus x1. So y plus 5 equals 0. 0 times x minus -2 is 0. 0 times anything is 0. So then I just have to subtract 5. Y equals -5. So here is my equation of the line y equals -5 that is parallel to the line y is equal to 2. And you don't have to do this. You don't have to use point slope, because if you just understand, well, if it's going to be parallel to y is equal to 2, it's going to be the same slope crossing through the y value of -5. So all I really care about is that y value of -5, because I want it to be parallel to that other one, because I want it to run the same way. It's a good example there, making sure we understand parallel and the equations there. All right, I think this is the last one. Yeah. Last one, nice little application question. Number 9, a coffee shop has learned that by pricing a cup of coffee at $3, sales will reach 400 cups per day. Raising the price to $5 will cause the sales to fall to 250 cups per day. Assume that the relationship between sales and numbers sold is linear. Write an equation describing this relationship. We're given two different pieces of information. We are given that $3 results in 400 cups. But then we are given the information that $5 results in 250 cups. What we're trying to figure out is we're trying to generate an equation here to determine, like, well, what if we price it at $4? So we have ordered pairs, right? We have ordered pairs. We have 3 cups is 400, 5 cups, I'm sorry, not cups. $3 is 400 cups, $5 is 250 cups. So I could just call this my x1, my y1, my x2, my y2. I can find slope, generate an equation from there. So let's go ahead and do that. So I'm going to find slope between these 2 points. And if I wanted to graph it, you could, but I'm just going to not graph it for now. So y2, 250, minus y1, 400. x2, 5, minus 3. So then we have 250 minus 400, which is going to be negative 150. 5 minus 3 is 2. Divided by 2 is negative 75. So we get the slope of negative 75. Just think about what that means. Just think about if we were to graph this. Just a quick graph. We're in the first quadrant. So 3, 400. And then 5, 250. If you look at this line, like if we were to create an equation, like look at this line, look what's happening. It's going down. So as the number of dollars increase, what's happening to the sales? It's going down. So it's a negative slope. That makes sense. As that X value is increasing, as that price is increasing, the number of cups is going down. Do we want an equation? Yeah, write the equation. So we got to write the equation now. So y minus y1 equals the slope of negative 75 times x minus the x1. So y minus 400 equals negative 75x. 75 times 3, not trusting my mental math, 225. So plus 225. Add 400. So y equals negative 75x plus 625. So here's the equation that I could use to make predictions based off of this information. What do we want to predict? It says predict the daily sales of coffee if the price is $4. So remember, x is the dollar amount, where y is the cups per day. The pricing point is x. So we want the price of $4. So this question is just asking us to substitute in, what is it, $4? X equal to 4. So we'd say y is equal to negative 75 times 4 plus 625. And then y would be the amount of cups sold. So we're going to do negative 75 times 4 plus 625, which is 325. So y is equal to 325. So at a price point of $4, we would expect to sell 325 cups. So $4, we would expect to sell 325 cups. That's what that information is translating to. So I like these scenarios because we can make actual business applications off of this, and you can see the impact on how businesses might make their decisions based off of some models that they have. And it's not always going to be a linear, because we're assuming a linear relationship here. That's not always going to happen. And that's like if you're going on to like business calc, you might look at some nonlinear relationships. But for right now, that's just a good problem there.